Welcome back to another edition of, hey, you can't park that there. We're going to test that tab that we welded on last video. All right, this little guy right here. We're going to do a little science experiment just to see how much it holds, right? Like, why not, right? So what I have is I have a plastic bag, right? I have a 5-pound dumbbell, okay? So let's start off with 5 pounds. Let's see if this thing can hold 5 pounds. What do you guys think in the comments? Do you think it's going to be able to hold 5 pounds? And that's going to be it. All right, you ready? We're going to lift up. You're going to see this together on the count of 3. 1, 2, and 3. Guess what, guys? Our tab held. I could even bounce it. Can even bounce it pretty good. Okay. Let's try another one. Over here, I have, let's take the 5-pound weight out. So we know it works with 5 pounds. Now I have a 15-pound weight. So we're jumping it up quite a bit. Now, I don't know about this. This might be our breaking point right here, folks. This very, very well might be our breaking point. This is considerably heavier than the 5-pound one. And this is just a very small welded tab that I didn't really spend a lot of time per se on. So, I don't know. What do you guys think? Do you think yes? Think it's gonna hold? No? You don't think it's gonna hold? What do you think? You ready? Okay, 1, 2, 3. Holy crap, guys. You've seen this, right? This is holding. Make sure I don't bounce it over top of anything. Holy crap, I can bounce it. That's 15 pounds. That's 15 pounds. 15 pounds that thing held on a bounce, on a lap shear stressor. Well, let's do 20 pounds. I don't know if the bag will hold too much more than 20 pounds without ripping, so I don't feel like breaking a toe. So we're gonna cap it at the 20-pound rate. All right. But hey, I'm curious now. I'm hopeful. I'm hopeful. Go all around there. Yeah. Okay. So 20 pounds of testing was our limit. It started shearing off pretty quickly. But I'd say honestly, that's enough to hold any tab, right? When you think of what we're doing when we're repairing something, are we trying to make it indestructible? Nope, because that's not what it was designed for in the first place. When the manufacturers make something, they make it designed to give way at a very specific threshold, right? It's designed to absorb energy. So if we make everything wildly strong to the point where it's never going to break off, we're not doing it right. Okay. Now there was ways that I could have made that tab just a little bit stronger than I did. I could have made a little channel down the middle and the inside of that tab, and then just welded a bead right down the center of it all, and that would have held it. Then there wouldn't have been a weak point, right? So essentially, the weak point of our entire weld was the fact that we had no weld all along that flat surface right there, right? So understanding how to do a weld and how to do it right and how to cover every different base is understanding what that weld needs to do in the first place. I welded that tab on here as a simulation because a lot of times on these rocker panels, that's right where those tabs go, right? And so yes, we wanted to eventually give way. We had 20 pounds of pressure there, right? Any kind of accident that's going to duplicate the same kind of inertia, right? And that thing's going to give way. This part's going to rip and break, and it's going to absorb damage. That's the entire purpose of the plastic parts on the car, is to absorb impact damage, right? If we make it so it's not absorbing, then we're just transferring that energy farther into the car where it's not designed to, right? So we always want to make sure that even though, hey, you can't park that there, really, in reality, yeah, you can park it there, but only if you do it right. Hit that like and subscribe, follow along.